Hello students, I hope you all are fine. So today we will discuss about the carboanion. Students, yesterday we have discussed about the carbocation. Okay, these are the intermediates. These are the intermediates. So today we will discuss one more intermediate, that is the carbon anion. Okay, so what do you mean by the carboanion? In carbocation, what was there, students? Carbon has positive charge on it. Carbon has positive charge on it, and it has 6 electrons in its valence shell. But in carboanion, carbo means carbon. Anion means carbon is carrying negative charge. Carbon is carrying negative charge on this one. Okay, like students, this. So in carboanion, carbon carry negative charge. Carbon carry negative charge. First point is this. And students, carbon has 8 electrons in its valence shell. In carbocation, we have discussed carbon has positive charge, but in anion, carbon has negative charge, because anions are the negatively charged species. Okay. In carbocation, carbon has 6 electron in its valence shell, but in carboanion, it has 8 electron in its outermost cell or valence cell, we can say. Clear or not? Yes. So students, how can we produce carboanion? Like if we have ethanol, okay, CH3CHO, aldehyde it is, acetaldehyde is the common name for this one. Okay, students, in ethanol, I can write in this way CH2H, CHO, carbon forming double bond with this and single bond with hydrogen. In this way I can write or not? Yes, yes. Students, what will happen if one nucleophile will attack on this one? This is nucleophile because it is negatively charged species, it is electron efficient species, and electron efficient species are known as the nucleophile. Okay, it has tendency to give electron here because it have extra electron, lone pair also, and negative charge also it is having, so it can lose electrons. Okay, but why it will lose, beta? You can see here this oxygen is more electronegative as compared to this carbon, so it will try to take electron from this carbon, and availability of electron also here. Okay, the negative charge attained on this one and positive attained by this one. Okay, so if positive comes here, then electron deficiency take place, then this carbon can support this one, then positive will come on this, and this hydrogen, one hydrogen can support this carbon. Clear? So finally H positive can be released. And one more thing, water is good living group. Okay, entropy also support this one. Then students, this oxygen can give electron to this one, and this hydrogen finally can be shifted in this way. And what will happen? H positive, OH negative, removal of water take place. Plus electrons of these bonds are accepted by this one. If it accept, then if it accept, then negative charge attain on this one, and these are the two electron which accepted by group. Clear or not? So you can see now here in this passage, carbon carry negative charge. Carbon carry negative charge. Okay. Then students, carbon carry negative charge on this one, and it is having, I can write in this way, the two electrons, negative charge, it is forming two bonds with, one bond with this carbon, one bond with this carbon. So you can see how many electrons are there? 2, 4, 6 and one pair of this one. So there are total 8 electrons in valence shell. Clear? Clear or not? Yes. What type of cleavage take place here? Heterolytic. What type of cleavage take place here? Heterolytic cleavage. You know very well in cation also, carbocation also heterolytic cleavage take place, then formation of carbocation take place. Okay, and during formation of carboanion also heterolytic fission take place. Clear? But in free radical homolytic take place. Clear? So first of all you should know carboanion. Carboanion is that species, is that chemical species in which carbon carry negative charge and carbon has 8 electron in its valence shell, and formation or we can say production of carbocation takes place due to the heterolytic cleavage. Due to the heterolytic cleavage. It is clear or not? Any doubt in this? Yes. Then students, orbital structure. Orbital structure. Carboanion. Carbon has negative charge. It has 8 electrons in outermost cell. This is carboanion. Methyl. This is methyl carboanion. Carbanion. Yes. Students, if we discuss about the orbital structure, then you should know about the hybridization. You should know about the hybridization. And you know very well how we can calculate hybridization. So students, in hybridization, we will see number of the bonded atoms, plus number of lone pairs of electron, plus number of lone pairs, not pair of electron, just lone pair we will see. So students, how many bonded atoms are there? 1, 2 and 3. So there are 3 bonded atoms plus lone pair it is, plus 1 lone pair. So 3 plus 1, 4. And if this value is 4, then what will be the hybridization? sp3. 4 orbitals total. 1 for s and 3 for p. Hybridization will be sp3. Okay. So here hybridization is the sp3. And you know very well, for sp3 hybridization, what will be the geometry? Tetrahedral. But students, it has pyramidal shape. It has pyramidal shape. Why it is? Because one lone pair also present on it. One lone pair also present on it. So how can we Draw structure for this carbon having one lone pair of the electron. It is having negative charge also. It is forming three bonds with the hydrogen. So in this way we can draw structure. Clear? And what type of shape it is? It is pyramidal. It is pyramidal. Hybridization is sp3. Hybridization is sp3. Clear? Angle for sp3 for regular it is 109 degree 28 minute. But one lone pair is here, so it will be less than it. It will be less than 8. Clear? Around 108. It will depend on each. Clear or not? Here CS3 group also may be present, primary, secondary, tertiary. It will depend on that. So, but it will be less as compared to this one due to presence of the lone pair. Due to presence of the lone pair. So, students, its shape looks like the NS3 because in NS3 also in ammonia also there are 3 hydrogens and one lone pair of electron. Clear or not? So, like NS3. So students, it is all about the orbital structure. It has sp3 hybridization and pyramidal shape. You can draw in this way. You can draw in this way. Any doubt in this? Clear? Yes. Then students, classification. You will see the classification. You will see the classification. Like carbocation, we can classify carboanion also as methyl carboanion. Primary means carbon is forming one bond with other carbon and other two bonds it is forming with hydrogens carrying negative charge also because we are talking about carboanion. Okay, so primary, this is methyl anion, primary. Secondary, in which carbon form two bonds with other carbons and other third bond it is forming with hydrogen carrying negative charge on it. Okay, it is secondary. And in tertiary, all three bonds forming with other carbons carrying negative charge. It is tertiary. Okay, so students, we can classify carboanion also in methyl, primary, secondary, tertiary. Methyl we can say 0 degree also. Sometimes we can say 0 degree also. Okay. Now we will discuss about their stability. You know, in carbocation, what was the stability order? 3 degree, 2 degree, 1 degree, then 0 degree. But here order is reversed. Here students, primary is more stable. Here. Means methyl more stable, then primary, secondary, and then tertiary. This will be the stability order. Okay, and you know very well, reactivity order will be reverse. reactivity inversely proportional to the stability. Reactivity inversely proportional to the stability. So reactivity order will be tertiary, secondary, primary, then methyl. Why it is? Now you should know. Okay, why it is? Why this order is reverse? Then students, during explanation of stability, first point you discussed there, stability of anion. What was the first factor? What was the first factor in stability of the carbocation? That was the inductive effect. That was the inductive effect. Here also we can take inductive effect. Inductive effect. We can also take here. Okay. Students, try to understand. If you are having tertiary anion, here three alkyl groups are present. Three alkyl groups, three methyl groups are present. And you know very well, alkyl groups show plus I effect. Alkyl groups show plus I effect. Alkyl groups show plus I effect. Means they have tendency to release electron. But students, this carbon is carrying already negative charge on this. Okay, and further they are going density on this carbon. They are going to increase electron density. Electron density on carbon. Already here carbon is negatively charged, already negative charge on carbon, and further these groups are giving electron to this one. Clear or not? So electron density increases here, which is making it unstable. Which is making it unstable. Now you will say, मैम अगर ज्यादा हो रहे हैं तो अच्छी बात है, बट हमेशा अच्छी बात नहीं होती. लाइक स्टूडेंट्स, रिसेंटली अभी हमने दिवाली सेलिब्रेट की है. ओके, हम पूरा दिन किसी के घर जाते हैं, कोई हमारे घर आता है तो क्या मिठाई स्वीट ही खिलाते हैं. हमें पूरा दिन क्या खिलाएंगे? स्वीट खिलाएंगे. तो लास्ट में जाते जाते शाम को क्या होता है, अगर हमें कोई स्वीट खिलाएगा तो ओवर ईटिंग हो जाएगी ना, ओवर स्वीट. देन वी विल प्रेफर एनी सॉल्टी डिश. वी विल नॉट प्रेफर स्वीट ना, बिकॉज मीठा ज्यादा हो गया है, ओवर हो गया है. क्लियर और नॉट? सो हम अब स्वीट में स्टेबल नहीं है. We need chili paneer like that. Means we need salty now. Clear? So in same way, carbon already, you know very well, carbon electronegativity is not so much. Carbon की electronegativity इतनी ज़्यादा नहीं है. After that it is carrying negative charge. And further they are saying, yes, you can take our electron also. You can take our electrons also. Further they are giving electron to this one. Clear? So electron density increases on this one, and which making it unstable. Which making it unstable. It is carrying or not? Sorry, it is clear or not? Yes. Any doubt in this? So student, here merged electron releasing group are making unstable it. Are making unstable it. But in reverse, when we were discussing about carbocation, try to understand. I am going to compare now. I am going to compare now. Here carbon has positive charge. Carbon has deficiency of electron. It needs some more electrons. It needs some more electrons. Okay. Here it is hungry. It needs some food for eating. So from where it can take? Where availability? So how many donors will be available? All will provide stability to this one. Here it is feeling hungry, but it is already overeaten here. Clear or not? So students, in carbocation, these alkyl groups are providing stability to this one. But here they are increasing. Already it is negatively charged. Further they are giving electron to this one. Further they are going to increase electron density on this carbon, and which is making it unstable. It is clear or not? Any doubt in this? Yes. Then students, so on basis of that we can say it is having more alkyl group, so it is making more unstable. Here only 2, here only 1, and here no one. Clear? So students, this one is more stable, this one is more stable, and this one is the least stable here. So this will be the stability order. This will be the stability order. 0 degree, 1 degree, 2 degree, and then 3 degree. So any doubt in this? So stability order of carbanion will be methyl carbanion 1 degree, 2 degree, 3 degree. And reactivity order just reverse. Reactivity order just reversed. It will be tertiary, secondary, primary, then methyl. Now any doubt? Clear? One more factor here. One more factor. Second one factor, in case of carbocation you discussed resonance. You discussed resonance. Here also, if number of resonating structure increases, then stability also increases. Number of resonating structures increases, then stability also increases. Like if I write in this way, CH2 double bond CH2 negative. Okay, then what will happen? These electrons can be delocalized. This pair of electron can make bond here. Yes or not? Yes. If it will make, try to understand. What will happen? CH2, it is forming double bond, and CH, it is also. So now count number of bonds with this carbon. 1, 2, 3, 4, 5. But carbon is tetracovalent. So further what will happen? This pair shifted here. Clear? Then students, it is the single bond. And CH2, this one pair of electron goes on this one, and it is accepting now. Clear? Either we can write in this way or we can write in this way. So both are the resonating structure. allylic. This one is the allylic carboanion. So here resonance is making stable. Due to resonance it is stable. Stable due to resonance. Stable due to resonance. Clear or not? One more last factor. I will take hyperconjugation, not factor here. Hyperconjugation, not factor here. One more factor we can take S character. S character. If students S character increases, then stability of carbon ion also increases. Stability of carbon ion also increases. Stability of carbon ion also increases. Like if I write in this way, R C double bond C, C triple bond C negative, and then I write Cr2 double bond CH negative. Here carbon carrying negative charge, here carbon also carrying negative charge. Okay, here students triple bonds, carbon to carbon triple bond, means hybridization will be sp. For triple bond I already told you na, sp, and for double bond it will be sp2, sp2. So you can see, if I take total 100, then 50 of S and 50 of P. So here S character is 50%. S character is 50% here. And here if I consider it 100 total, then it will be 25. Clear or not? So in this way, not 25 it is, beta. 33 point something. 33 point something. 33 point something. So here S character more as compared to this one. That's why it is more stable as compared to this one. Clear? So these are the three factors. So today we have discussed about carbon and ion. Any doubt in this? Okay. So tomorrow we will discuss about one more intermediate, that is a free radical. Clear? So thank you. Have a nice day.